It is 14 minutes past 3 in the morning, and an analyst at a tier 1 Indian bank sees a strange process spawn on a Swift operator's workstation. And the file is called PowerShell.exe, and it's running as a scheduled task created at 2:47 a.m. She pages her shift lead, and by say 3:20 a.m., there are three additional workstations all showing the same pattern. And by 3:45, volume shadow copies are being deleted on a file server. By 4:12, 9 minutes before the morning Swift cutover, an empty 103 message for 4.2 million US dollars to an offshore account leaves the queue. This is not a training scenario. This is what 2024 looked like for a bank that you would have perhaps read about in the newspaper. The difference between that bank and the next one, how the people responded in the first 90 minutes of that cyber attack. Every dollar your organization spends on cyber training presumes that when this moment comes, your analysts will know what to do, in what order, under time pressure, while a board member is asking you on a conference call whether to disconnect from Swift or not, and that decision will cost the bank 140 crore rupees in settlement penalties either way. How do you know that they can do it? How do you know that your cyber team is prepared or not? That question is the reason why Battle Stations exists in Critical Range. It's Critical Range's cyber defense engine. It's a live fire, scenario driven, multi team platform that puts your analysts, your incident commanders, your legal counsel, and your executive leadership into the exact situation that I've just described. Together, under pressure, and with the whole exercise instrumented to the minute. Let me just open up Battle Stations for you here. That's a session that we started, we played, and then we paused it. This is called Operations Cyber Kavach. Kavach is Sanskrit for armor. This is a 4-team exercise modeled on an APT class cyber attack. So think that a state-sponsored APT is after you, and they're about to execute a potential Swift banking environment. As I said, the game is paused and the red team has landed. Teams are in incident phase at the moment. As you can see that this is incident phase that's going on in the moment. And let me walk you through the command surface that your team, that your people will be using when the real version of this happens to you, because it always happens. All right, let's see. Before I click into the exercise, let me anchor the vocabulary. What we're looking at is a CDX, or a cyber defense exercise. It is structurally different from every other training platform or every other training format that vendors would try to sell you. A capture the flag will test individuals, whether one person can solve a puzzle or not. A course teaches concepts, whether a person can pass a multiple choice question or not. A red team engagement tests your infrastructure. Can a professional adversary get in? But it doesn't test your people responding. A tabletop exercise tests in like executive decision making, but on a whiteboard, not on live systems. A CDX, or a cyber defense exercise, if it's done properly, is the only format that tests all of them at once. Your technical teams are patching services. Your incident commander is coordinating. Your legal counsel is deciding whether to notify your regulator, and your CISO is debriefing the board. The adversary could be scripted, could be live, could be human, could be AI, is continuously escalating. The services your business actually depends upon, email, web, banking gateways, are all actually going up and down. There is a scoreboard, there is a timeline, and there is no pretending. This is the format that's used by NATO's Locked Shields, the US Cyber Guard, and increasingly by Indian cyber defense agencies. Until Critical Range, running a CDX required around 20 odd consultants, 6 weeks of preparation, and between 2 to 5 crore rupees. Battle stations reduces that to what you're looking at just now. Self-service, deployed on your infrastructure, fully air-gap capable, with 4 teams live in under 1 hour. This is the battle station's dashboard, the single surface every participant and every observer lives on during the exercise. Let me orient you from left to, because the layout itself encodes the philosophy. Now, at the top, you can see that there's a phase ribbon. A battle station's exercise usually has got 6 life cycle phases: setup, reconnaissance, attack, incident, recovery, and debrief. They are mapping into the NIST incident response life cycle. You can see that setup, recon, and attack are complete, green ticks, and incident is active at the moment. That's the pulsing pill. Recovery and debrief are ahead, and at any moment during the exercise, every team knows exactly what phase they're in, and it tells them which playbook applies. This matters because the wrong response in the wrong phase will cost you points, but in real life it will cost you breaches. And if it's an OT environment, an ICS environment, it can potentially cost lives. Now, the row below this line here is it shows us that the exercise has been running for some time now, and we are progressing through multiple rounds, is what it's trying to tell me. Now, if you look at the service status column, right here, this entire patch of service status, it tells you what is running right now. These 5 cards are the business critical services that this Alpha Bank has committed to defending: the customer web portal, the DNS server, the mail gateway, the Swift messaging terminal, and the SIEM log collector. Each card shows a percentage SLA. It shows you a status icon. It shows you a response latency, and when was it last checked. Notice that these colors can keep changing. They can go down to amber, which means that they're degraded, which means it's slow, or maybe it's intermittent. It's up, but it's slow, which in banking context is actually worse than down, because you discover it after the customer complains. The center column is basically injects over here. Now, the injects is what in the world is doing to us view. You get a perspective of the injects that have been delivered to this team so far, and as you can see that, let's have a look at this external scanning detected from the recon phase, and then there is another one over here which is phishing campaign identified, where a user reports of suspicious email. Then there is another one here called lateral movement detected, where the moment the SOC realizes that this wasn't an isolated incident. Ransomware precursor activity, where volume shadow copy deletion events occurred. And Swift terminal compromised, which is the red flag incident. And then there was a media inquiry received where a journalist called and is on hold. And then there is a board notification required where the chairman wants a brief. And then there is the system restoration priority, which is the operations team wants direction as to what to do to bring it back up first. Every one of these injects is a decision point, not a question with the right answer. It's a decision with trade-offs under time pressure. This is how incidents actually feel, right? Now, if you can see, there's an option over here for quick incident report, and this is what we are doing about it. That's what you're trying to portray here. Any participant, including the blue team captain, can file an incident report directly from here, or if you want details in incident reports available here, where you go threadbare into filing the incident report, and you basically specify the severity, the title, the affected systems, what actions have you taken, and then the white team reviewer scores it within 15 minutes. And that's what we are trying to show here: services, injects, and response. And if you look and notice here, I'm actually white team. You see this? Let me change the color to a little light mode so you can see. I'm a white team player who's playing this game at the moment, because I'm logged in as the exercise controller, not as a participant. And when I switch to a particular team, say Alpha Defense, using the team selector on this top panel, the same layout rescopes to only show alpha services and only alpha injects and only alpha scores. So it's a role-based isolation that's enforced at the server level, not just at the front end. And a participant cannot see other teams' screens. So we're not pretending privacy. The tenancy model itself enforces it. I'd now like to talk about the topology view. This is the battle space. Most cyber range vendors will show you a drawing, a pretty diagram. What you're looking at here is a live derived topology. It's derived from actual IPAM IP address management state, from the IPAM allocations that the orchestrator provisioned when the exercise started. If a virtual machine rebuilds, this topology will update. If a new team is added, a new container appears. It's wired from truth. It's not wired from Photoshop or draw.io or draw. Let me walk you through the hierarchy that the way it maps to how a network engineer thinks. 4 team containers tiled across the canvas, and you've got team Alpha, team Bravo, and all these. And each team defends its own isolated network. The Alpha defends on the 10.1.0.0/16 subnet. This Bravo is on 10.2, and similarly this Charlie is on 10.3, and Delta is on 10.4. Okay. The color of each team matches the team's jersey. So they're wearing these t-shirts or their jerseys at that time. This matters during a 2-hour exercise where the incident commander is shouting, "Charlie, patch your mail server," and the green container is the one that everybody will have to then start looking at. You know that inside each team there's an enclave. There is, as you can see, there's a dotted container over here. That's the enclave. Any real enterprise networks are usually enclaved. You'll have production, corporate, DMZ to internal separation. So in this exercise, which we're calling as Cyber Kavach, each team has a single enclave containing 2 zones. And this could be more complicated. It could be a hierarchical topology where you've got one head-end router under which you've got a different firewall. It could be a Cisco, a Palo Alto, a Juniper. It could be a pfSense, an OpenSense, or anything, any model. And the DMZ is basically public facing and the internal zone is protected. This mirrors exactly how banks actually deploy Swift. The customer facing web and DNS sits in the DMZ, and a Swift terminal and a mail server and a SIEM will typically sit behind it. Each zone has a gateway. That's where you see the 10.1.0.1 IP address, the 10.x.0.1 IP address, and the role, and you've got individual role VMs. Every VM's playing a role. For example, in the DMZ, you've got the web portal and the DNS server, and in the internal zone, you've got the mail server and the Swift terminal and the SIEM collector. Now, look at the top, look at the team row. Let me expand it a little bit. Look at Team Bravo over here. If you see on this row, what I want to show you is something above this. Let me reset this. Yeah. Now, that's the command and control of the red team over there. There are 2 external facing nodes, the red team command and control on the left hand side, and that's the adversary's infrastructure, by the way. And the tag T1071 is the MITRE ATT&CK technique identifier for application layer protocol, standard APT-C2 signaling. There's a perimeter firewall on the right hand side, and that's the edge device gating traffic into each team's gateway. Now, if you look at the edges, there are these toggles that I can toggle around, and I can see individual teams or I can see all teams. Those options are available here. And if you want to see, this is one of my favorite views. You can see it in a not a 3-dimensional view, but it's a 2.5-dimensional view split where you get a better perspective of the entire topology as to how the devices are connected with each other. I like to call it the terrain map view for presentation, for executive briefings, for recorded videos. The tilt gives the brain a spatial reference. This is where the attack came from. This is where it landed. This is how it propagated. And you cannot narrate, I believe, an incident in a flat diagram. A 2.5 diagram, a 2.5 dimensional diagram, it tells the story and makes it a little bit more obvious. The crucial design principle behind this page is that every node that you see corresponds to a row in the IPAM database. This is a dynamically created topology which corresponds to a row in the service check table and corresponds to an inject that may target it. When I open the services page next, which I'll just show you, you will see that the same 5 service member names that you just saw in each zone, the web server, the DNS, the mail, Swift, and SIEM, rendered as columns in a heat map, and they're cross-referenced in very visual and intuitive manners. And that's the integration that I haven't seen any competitor in the market offering thus far. All right, let's see. Now, this is the services status heat map that you see in front of you. This is the view that the incident commander looks at every 30 seconds. It's the page that you project on the wall during a real incident. It's if you've been inside a telecom network operation center, you've seen something like this. Rows are systems and columns are services and color is health. Now, the 5 columns are the 5 services we just saw in the topology: DNS, mail, SIEM, Swift, and web. Same name, same order as the IPAM layer, and that's a one-to-one correspondence, and that's what ties the dashboard to reality. In legacy platforms, these are just different lists with a mild overlap. Here, they're literally the same data rendered 2 different ways. Each row is a team. Each cell shows that for that team's instances of that service in round 3, the SLA percentage, colored status icon, and a mini progress bar. So you can see this score for Charlie Guard, for Bravo Shield and Delta Fortress and Alpha Defense, etc. Now, let's see. If I were to click on this, it gives more details. I can scrub back. I can see how everybody performed in round 1, round 2, round 3. I can get that visibility over here, how every single round was enacted upon. And if I were to click on any cell, it opens the side panel, side sheet, and gives me more perspective on how the scoring's gotten impacted. All right. And this, when it's taken to full screen view, this is meant for a projector in a war room. Real CISOs and real incidents want this view without browser Chrome, just one click. And that's what Critical Range promises. Now, we've talked about inject feed, and injects are the engine of this scenario. Every real incident unfolds through information arriving in your SOC. This could be an analyst's alert, it could be an IT ticket, it could be a journalist's phone call, it could be a regulator's notice, it could be a CEO's WhatsApp. And Battle Stations models each one of them as an inject, a very structured, timed, markdown formatted message that's delivered to participants exactly as if it would have arrived in the real world. So inject 1 is the external scanning, inject 2 is the phishing campaign, inject 3 is the lateral movement detection, and inject 4 is the ransom precursor activity. And this is where I want to pause. If you look at the badge, it says it's a 10-minute deadline. The inject gives the team 3 responses. You could either isolate the server, or you could keep it online to preserve forensic integrity, or you could potentially escalate to the CISO. Each option has got trade-offs. Each is a real playbook decision, and the clock is running out. If the team does nothing for 10 minutes, they will lose points for incident response automatically. All right. So yeah, that's what injects is. And then there is of course, the incident response page that you see over here. Every cyber range in the market can show you an attack animation. Very few, in my opinion, can show you the defender's written record, the narrative of what happened, what did they do about it, and what happened next. That record is what turns an exercise from a game into a credential. This is the incident reports view. You can see that reports are submitted here, and you basically write down an entire history of what has happened in detail. All right, now let's have a look at, we've seen topology. Maybe we could have a look at the AR, which is the attack, the after action report, the after action review. Now, this is where Battle Stations becomes a training system, not an exercise tool, the after action review. In real military doctrine, and I use that word deliberately, the AAR is the moment that separates a drill from a learning event. The phrase comes from the army, which means that what was planned what happened, what was the difference, and why. Every exercise we run here ends in a structured AR automatically generated from live data that you've just seen. It gives you an exercise summary, which tells you how many hours the exercise ran, how many teams participated, how many phases were there, and it gives you a status of the incident phases which are active. This is not manual input. This is all derived from the session state. And then it gives you a beautiful timeline reconstruction, every event in order, which phase started, ended, what was the red team's action, what injects were delivered, what incident reports were filed, score overrides which were applied. So you can see multiple events are visible here. And this becomes a forensic timeline. The same view an incident commander would produce after a real event, but in this case it's auto-generated and not manually stitched together. And then you have a beautiful scoring breakdown, which, where you see all 4 teams, all 4 tracks, overall score, an SLA percentage. This is the version that appears in the PDF export, the document that your CISO sends to the board on a Monday morning. And then you've got your MITRE attack coverage framework. You're looking at the MITRE matrix we saw in the red team log, but now rolled up per technique across all teams. How many teams detected the technique? How many teams detected the technique? How many remediated them? The organization's detection rate. This is how you identify the semantic gaps. If all 4 teams, say this one, as you can see, all 4 teams missed the T1021 RDP lateral entry movement, and that's not a training problem. That's a detection engineering problem. And then you see this team comparison radar. Breaks down all 4 teams, all 4 tracks, overall score, SLA percentage. This is the version that appears in the PDF export. It gives you 4 spokes, 1 per track, 4 colors, 1 per team, and it tells you at a glance which teams are balanced and which are one-dimensional, which teams are good technically but poor strategically. They're good in legal, but they're not good from an incident response perspective, right? Yeah, these are key findings. This is something that's very important for a CISO to know about their team, that what's their average MTTD, mean time to detect and respond to an attack, and what is the percentage of detection rate. This is not conjecture. This is not guesswork. This is real data derived out of metrics after a battle stations exercise. You could, of course, invoke AI, and AI is going to invoke a fairly nice written narrative of the entire incident for you to put into the PDF submission report. This is optional. For organizations, excuse me, for organizations that have enabled an on-premises LLM integration, the AR engine produces an executive-grade narrative summary. It'll say teams performed strongly on incident detection, but collectively missed RDP lateral movement. Team Alpha Defense demonstrated exemplary scene correlation. Charlie was very good at threat hunting. Recommended training is that we strengthen T1021 detection and refresh the legal communications playbook. So it does that for you. If you have a local Llama implementation, we can integrate with it, and you'll get all these reports integrated into the AAR. Before I close, I want to take a step back. I want you to see the geometry of what we watched. We saw topology view, the map of the battle station where the fights happen. We saw the services heat map, the real-time service status dashboard, what's up, what's down, what's degraded per team, per round. We saw injects, which is the scenario, what the world is doing to us. We saw incidents, which is our response to what the world is doing to us, what we did, what we documented, reviewed, and scored. And then we see the scoreboard, which gives us a perspective of the measurement, who performed and what went well and what didn't. This is the after action report, the learning. What did we take back to work? And now think about how all these 6 surfaces relate to each other. They're all views of the same data. The topology, where VMs exist. The heat map is the service on that VM, whether it's healthy or not. And the inject, that's where the scenario signal from that the attack happened. And the incident, which is the team's documented response. The scoreboard, which is the weighted measurement of the response, and the AAR, which is the rolled up learning. You do not get a service heat map that knows about injects without this integration. Competing products force your team to stitch this together. They will give you a map in tool A, they'll give you a scoring sheet in tool B, and inject as a PDF mailed externally in tool C, and AAR, that's a template in PowerPoint. We give you a single session with 7 views, or 6 views rather, over the same data, each written for a different persona, each clickable, each exportable. That integration is our architectural commitment, and that is why we believe that Battle Stations is the most advanced cyber defense exercise engine on the market today. One more time for the CISO: measurable, repeatable, exportable, auditable. That's the key word that I'd like you to remember, that these are the 4 properties that your board wants from every dollar, every training dollar that you spend. And every feature that I've shown you today is of service in those 4 words: measurable, repeatable, exportable, and auditable. Now, in closing, what I'd like to say is that we built battle stations for Indian enterprises, Indian banks, and Indian defense establishments who are paying multi-crore rupees to foreign vendors to run one exercise a year, using infrastructure hosted outside sovereign boundaries, with data flowing to clouds and cloud regions outside this country, with pricing tied to unpredictable foreign exchange movement. The buyer had just one lever and commission another exercise. The outcome was one CISO briefing on one Monday once a year. We architected it differently. We made a platform called Critical Range. It's deployable on your infrastructure, something that you own. It's air gap capable, which means that we're not sending any telemetry data out. There are no external dependencies. When you need it to be locked down, it can get locked down. It's self-service, which means that your trainer launches an exercise in under an hour, not in 6 weeks. It's bilingual today, which means it's English and Hindi, and it's expanding to other official Indian scheduled languages. It's priced in rupees, it's not priced in dollars. It's aligned to Indian regulatory frameworks, the RBI cybersecurity framework, the CERT-IN advisories, the DOT directives for telcos, the DPDP Act for data protection. And the feature set that you've just seen, the 4-track scoring, the integrated life cycle, the MITRE attack coverage, the AAR generation, is already at parity with the top tier products out there like Cyberbit, Cybex, SimSpace, etc. And on some dimensions, the scenario-driven injects, the bilingual support, the sovereignty model, we are way ahead of the competition, and we ship updates every 2 weeks. So for the CISO in the room, when a regulator asks you, how do you know that your team is ready? You now have an answer. It is a PDF. It is a timeline. The PDF will have a timeline. It'll have a MITRE matrix, a 4-track scorecard, and a summary. It will be generated in 10 seconds. It is signed with your organization's key. For the training leader, your analysts do not need another multiple choice quiz. They need 3 hours of live pressure, with live consequences, with live training and live scoring, and a structured debrief immediately after that. That is why Battle Stations delivers. It's one platform, unlimited exercises per year with your subscription, curated scenario library, plus you author your own exercises. For the procurement team, this is deployable in your existing infrastructure. We leverage OpenStack or on-premises isolated lab. It's licensed per tenant. It's not licensed per user. So you don't have to pay for every analyst that you add. It is GEM listable. It's aligned to national sovereignty. It's backed by the Critical Range engineering team based out of India, contactable in Indian business hours. What you just saw was Cyber Kavach. It was one of our hundreds of exercises that you can run on this platform. This is one of the 5 exercise families that exist in Critical Range. There is CTF for individual learners, there's courses for structured curriculum, there is battle stations for team defense exercises, there's war games for attack defend, and there is crisis simulation for executive decision making. All under one subscription, all of them integrated to give you one unified scorecard to help you understand where you're proceeding in your cybersecurity journey as an individual as well as an organization. One platform, 5 exercise families, sovereign deployment, measurable readiness. That is our commitment. Thank you for your time.